So the next thing we're going to do is we're going to look at these steps to construct a frequency distribution, and we're going to simultaneously go through the second example where we'll actually work through those steps and construct a frequency distribution. So step one of constructing a frequency distribution is to determine the number of classes. Determine how many groups you want to break the data up in. And sometimes that might be given to you if you already have a table that you need to be filling out, like what we have in example 2. On some of the lab assignments, I will tell you how many classes to use, and then on some of the other lab assignments, you'll have data and you get to pick how many classes you want to use. Generally speaking, though, the number of classes that we use in a frequency distribution is usually somewhere between 5 and 20. 20 is on the larger side. 5 and 20 in general. 20 is on the larger side if you're working with a larger data set. Okay, so looking at this example here, step 1, we want to figure out the number of classes. Well, we already know that there's going to be 7 classes because that was given to us. So really quickly, example 2, this is a list of prescription medicine costs in dollars from 30 adults in a recent year. And we want to build a frequency distribution for this. So we're going to follow these steps as we go through them. And I know there's 7 classes because I've left 7 rows out in that table there. Okay, so step 2, once we know the number of classes, we want to calculate the class width. Remember, that's the difference between consecutive upper or consecutive lower class limits. And to find the class width, we're first going to calculate the range, and then we're going to take the range and we're going to divide that by the number of classes. And we'll see what we get there. So first, let's go find the range. Step 2, we want the class width. And what we just saw is that to find the class width, we take the range and we divide by the number of classes. Well, we already know that we want to break this up into 7 classes, so I'll go ahead and put a 7 in the denominator. Okay, so to find the range, what we're going to do is we're going to take the largest data value and subtract the smallest data value. The range is the difference between the largest data value and the smallest data value. So looking at our data set, what we need, and there's a comment in here, a link that has this data that we could copy and paste it, and shortly I'll show you how we could do this exact same thing in StatCrunch. Okay, so the range, which is really just the max minus the min in the numerator, the largest data value in this data set is 405, and the smallest data value is 155. So we have 405 minus 155 divided by 7, which gives us 250 over 7, which is about 35.71 in the calculator, but we're not going to use 35.7 as our class width because in the step where you find class width, you always round up to the nearest whole number. So if we're getting 35.71 for our class width, we are going to round up to 36. So now we know that our class width is going to be 36. Step 3 tells us to find the class limits, where it has a comment there that we can use the lower class limit as our first class limit, and then we can build the rest of the class limits using the class width. So the smallest number in this data set was 155, so I'm going to use that as my starting lower class limit. And then I can build the rest of these, so I need to figure out what all these other numbers are. Well, I know that I can build the rest of the lower class limits because I know that the class width is 36. So I should be able to add 36 and find the next lower class limit of 191. And then same thing again there, I should be able to add 36 and find the next lower class limit of 227. So I'm just going to continue adding 36 to all of these numbers to continue getting what these lower class limits are. Okay, so now we have all of the lower class limits, and we still have to go and fill out the upper class limits. So to get the upper class limits, I know that if this is, well, there's a couple ways you could think of it. If this starts at 191, then I can just go backwards one and say this had to end at 190. And then once I have 190, I can just continue adding 36 again. Or you can just keep thinking about what had to come before that. So if this is 263, this had to be 262. If this is 299, this had to be 298. And we can just continue to fill out the upper class limits like that. And then I also know that the difference between these two is 36, right? Because this is true for all of these limits, okay? That they have 36 as the class width between them. Okay, so now that we have our class limits, so we've done step 3. I'm just going to put a check mark. Step 4 tells us to mark a tally for each data entry that falls into each particular class. So what that means is going through this data set, and this might be a little time consuming, but first I'm looking for all numbers that fall between 155 and 190. So 155 does, I'll put a mark for that. 165 does, I'll put a mark for that. There's more. 68 down here, I see. Okay, so that gives me 3 for that first class. Onto the second class, numbers that are between 191 and 226. There's 2 of those numbers because we have 195 and then we have 200. Moving on to numbers that are between 227 and 262, there should be 5 of those numbers, and we just have to go through and count. I mean, I just know what the answers are, but we actually do have to go through and look at each number and figure out, is it between 227 and is it between 262? So 239 is, 252 is, 241, 256, 238, that's 5, and that's all of them. Between 263 and 298, and yes, this is a little time consuming, but generally speaking, we won't be making our frequency distributions by hand. We'll be using technology to do them, but this is how we would actually do it. We would go through and count all of these. So I'll just go ahead and fill in the rest of these. You can verify that these numbers are correct. Another thing that you could use to check is that when you add up all of these numbers, all of these frequencies, this should be the sample size, the total number of data points that are in the data set. So when you count how many numbers there are, that should be the same as when you add up all of those frequencies. So we have created our frequency distribution. Step 5 was to count those tally marks, which we were doing along the way. But that is how you would create a frequency distribution from scratch, just using pencil and paper.